The exercise 2 from metals and the extraction. So zinc is very important metal. Zinc is extracted from its ore, zinc blende, which contains zinc sulfide. The zinc sulfide is converted into zinc oxide in an industrial process. Describe how a zinc sulfide is converted into zinc oxide. So what we can do if we want to convert zinc sulfide into zinc oxide? What can be done? So we can heat in air or we can roast in air. Then write a chemical equation for this reaction. Like when zinc sulfide react with oxygen, you have to write a chemical equation for that. So zinc oxide is there, which is zinc sulfide is there, which is ZnS, reacted with oxygen. As a result, it will turn into zinc oxide plus sulfur dioxide. Then the equation must be balanced. The balance equation for this reaction, when two zinc sulfide molecules react with three oxygen, as a result, it produces two zinc sulfide plus two sulfur dioxide. This always remains the same, fixed. The zinc oxide is then reduced in the furnace. The term reduction means like removal of oxygen. Name a substance which we add in the furnace. So what we add for extraction of iron and for extraction of a zinc, which substance is added to extract them or to reduce them, we add a coke. Same thing like coke or a carbon react with iron oxide or a zinc oxide, it will form a zinc metal. Describe how pure zinc is removed from the furnace and collected. So what happened? The temperature of the furnace normally it's higher than the boiling point of a zinc. So first it will vaporize and then it will condense at the top of the furnace. So first the zinc vaporized and then it will condense at the top of the furnace. This is what we do in extraction of a zinc. The next question is related to extraction of aluminium. Aluminium is an important metal. Aluminium is extracted from its ore, the bauxite, by electrolysis. The bauxite is an impure form of aluminum oxide. To describe how aluminum is extracted from bauxite, include an ionic half equation, the reaction at each electrode, and the description. Means the process you have to mention. So first what we do electrolysis of the molten alumina, like basically bauxite is dissolved in a molten cryolite. And the purpose of adding a cryolite is to lower the melting point. And as a result, so bauxite, the description is added to the molten cryolite. What is the purpose of adding a cryolite? This cryolite will lower the melting point. It will lower the melting point of aluminum oxide. And it will concentrate the ore. Means we'll have more aluminum in it. And then what is the ionic half equation? Because aluminum oxide, we want to do electrolysis of aluminum oxide. So the ions which are present, it contain aluminum ion. So the ions which are present here, there are aluminum ions and there are oxygen ions. Aluminum ions are positive. Which electrode they will move? Anode or cathode? The positive ions.
Cathode.
So they're extracted or moved towards the cathode. And the equation for aluminum is +3. So if the charge is +3, it will take 3 electrons and it will form an aluminum atom. Where oxygen will move towards anode And as a result, when one oxygen ion move there, it will lose two electron and it will form oxygen atom. But we write equation for a molecule. So when two oxide ions are there, the two oxide ions, they will lose four electrons and it will form oxygen gas. So this is you have to write the equation at anode, equation at cathode, then what we do and how we carry out this electrolysis. That's about the extraction of aluminum. The ionic half equation I already wrote for anode and cathode. Explain why anodes have to replace regularly. Because what happened at anode, the oxygen which is formed at anode, so oxygen which is formed at
Sir.
anode, yes.
Sir, Umar says he can join the class.
Yeah, I read his message. I just read the message. Oxygen formed at anode will react with the carbon at anode due to high temperature. So due to high temperature, there's a reaction between a carbon and oxygen at anode. That's why we have to replace this anode regularly. Then give two uses of aluminium and give a reason why aluminium is suitable for each. So what are the uses of aluminium and why it can be used by? So example, if we say we use it to manufacture aircraft bodies. So what is the reason for that? Because it is having a low
Or to
density.
cover food, aluminium foils.
Low density.
Yeah, low density. If I say aircraft bodies, then the answer, it has a low density.
So we can use them as a foil, aluminium foil.
Yeah, food container or cooking foils we can use because it resists corrosion. So if you mention a foil, aluminum foils are used. So why like a food covered with aluminum foil? Because it does not rust or it resists corrosion. Due to the oxide layer.
So can we say it traps heat?
Traps heat, yeah, good reflector. But chemical properties you have to mention with like trapping a heat is simply related to physical. A chemical property which enable us to use aluminum for like specific use of aluminum. Then in question 5, solid copper to carbonate undergo a thermal decomposition. Whenever we heat the metal carbonates, it will produce metal oxide plus carbon dioxide. So if we have a copper carbonate, it will, so copper carbonate, copper is plus 2 is there, valency, and carbonate valency is -2. So copper carbonate is CuCO3. And the appearance of a copper carbonate, it is green in color. When we supply the heat energy, the thermal decomposition of a copper carbonate gives copper oxide plus carbon dioxide. And this copper oxide is black in color. So they ask, state the color change for a solid seen during the reaction. So what is the starting color? What will the starting color of this reaction?
Sir, white.
White or green? First, we have copper carbonate. A copper carbonate is green in color. This copper, a solid copper carbonate is heated and it turned into copper oxide, which is black. So the question is, what is the color change of a solid? So starting color
What
is
do you mean, sir?
green. What?
I don't get it.
The question is, a solid copper to carbonate undergo a thermal decomposition. Means we are supplying heat energy to copper carbonate, so it decomposes, it break down. In a thermal decomposition, we have one reactant and we have more product. So we have copper carbonate first, and when we supply the heat energy to the metal carbonate, the copper carbonate, it turn into copper oxide plus carbon dioxide. The question is, state the color change of a solid during this reaction. So what is the color change of a solid? Like copper carbonate is green in color and copper oxide is black in color. It's a black solid. So the question is, what is the color change of a solid when this decomposition happen, when we supply heat energy to copper carbonate? So what is the start color or starting
From
color?
green to black.
And then what's the
Green.
final color? It will be black. And then they ask, write an equation. So I already wrote that copper carbonate decompose into copper oxide plus carbon dioxide. In question 6, aluminum is extracted from aluminum oxide by electrolysis. Why aluminum is not extracted by heating aluminum oxide with carbon? Like if we have aluminum oxide, Al2O3, and we use a carbon, why this won't work? Why there is no reaction in this case? What might be a reason for that? Anyone having an idea why aluminum cannot be extracted by reacting with coke or a carbon? Why by electrolysis only?
Because aluminium, because carbon is, I think, weaker.
Yeah, it's
Yeah.
less
So carbon
reactive.
is less reactive.
Weaker.
That's
There
right.
is no displacement.
So carbon is less reactive. It cannot displace aluminum. So answer what you mentioned, that carbon is less reactive. It cannot displace aluminum. That's why this reaction will not happen or occur. So for highly reactive metal, we use electrolysis of the molten compound. For less reactive, moderate reactivity, we can heat with coke or a carbon. And the least reactive, we can simply supply heat energy. So we have to complete the dot and a cross diagram for one aluminum and one oxygen. Aluminum is, when you check, because you have to use a periodic table, aluminum is 3, 13, and 27. So how the electrons will be arranged in aluminum atom? Like it will have 13 protons, it will have 13 electrons, and it will have 14 neutrons. But if we have an aluminum ion is plus 3 or 3 plus. So it will have 13 proton. How many electrons will be there? Because plus 3 means more proton than electron. How many electrons?
10.
So it will have 10 electrons and it will have 14 neutrons. The question is, we have to complete a dot and cross diagram for aluminum and oxygen. So aluminum, so it's already like with 10 electrons, we have to arrange. So first shell 2 and second shell 8. So this is already done. We have to complete for oxygen. Now for oxygen ion, like oxide ion. So oxygen, when you check the periodic table, it is 8 and 16. Means it has 8 protons, it has 8 electrons, and it has 8 neutrons. But oxide ion, oxygen belongs to group 6. So group 6, which ion it will form? -1, -2,
-2.
-2. If it forms -2, then it has 8 protons. It has
So
10,
it will
10
be 10 electrons.
10 electrons. So we have to arrange the 10 electrons here. First shell 2 are arranged. Then second shell.
8 in the outer shell.
Yeah, second shell. First we draw, because oxygen was having total 8 first. So 2, like dot representing the oxygen electrons, and 2 it took from aluminum. So we represent the other 2 by cross, and the charge will be -2. What does it mean? It means that 8 electrons belongs to oxygen and 2 it took from aluminum. That's why we represent them by a cross. Is it clear this how to draw an oxide ion and why we use a different symbol for the 2 extra electrons, as it's not belongs to oxygen. These are the electrons from aluminum.
Yes, sir.
And there will be an ionic bond. The melting point of aluminum is above 2000. Why aluminum oxide is having a high melting point? This is related to bonding and structure.
Because
2
it
marks.
is a solid.
No, but why it is
Hard metal.
solid? That, yeah, so the one thing, whenever you're referring to a melting point or a boiling point,
Lattice.
so you will mention aluminum ion, like there is a strong electrostatic attraction between the oppositely charged ions.
Yes.
So we need lot of energy to separate. 1 mark, that strong force between,
Electrostatic force. Can we say that?
yeah, strong electrostatic force, because the force between the charges is known as electrostatic. So strong electrostatic force between the oppositely charged ions, positive and negative ions. That is 1 mark. The second mark is, we need, whenever a question is there, why a substance have high melting or a boiling point, the second mark is for like lot of energy or too much energy is needed to separate them or to break the attraction.
To break down the. Yes.
So the second mark is always to break down or to separate.
So what chapter is this?
This one is actually related to bonding and structure.
But
Like this part is specifically from bonding and structure, but the main exercise is metal. This exercise is related to metal and extraction of the metal, but some parts are there which are related to bonding, because like it's not like in chemistry, you don't find a whole question from one chapter. It's like one part belongs to chapter 1, another chapter 4. It's they are related to each other. So aluminum can be extracted by electrolysis using the apparatus. As you can see, we use this apparatus to extract the aluminum or to separate the aluminum. Name the type of the particle responsible for transfer of a charge in the wire. Which particles are moving in the wire? Which particles always move in the wire?
Negative.
No. The particle, electron, proton, neutron.
electron.
So electrons are there, which are always responsible for the transfer of the charge in the wire. So if the question is which particle is moving in the wire, which particle transfer the charge in the wire, your answer should always be electrons. And in the electrolyte, in the solution, what we have always ions. You can say positive and negative ions, or you can simply say
Both.
Yeah. So positive and negative ions are responsible for transferring a charge in the electrolyte, and the electrons are responsible for transferring the charge in the wire. 2 reasons why we add a cryolite. You can see a cryolite is added here, aluminum oxide with cryolite. So what is the reason for adding a cryolite? Number 1, whenever we add a cryolite, it lower the melting point.
Speed up.
Yeah, it not speed up, it lower, it's not a catalyst, so you cannot say speed up, that is wrong. It's lower the operation temperature, or it lower the melting point of aluminum oxide, and it increase the conductivity, like it has more particles in a cryolite. So as a result, it increase the conduction, or you can mention it used as a solvent. So 1 mark, it lowered the melting point of aluminum oxide. So it can melt at very low temperature. The second mark, it increase the conduction. Like it increase, more charges are there. And third, you can also mention, they did not ask for third, but you can also mention it is used as a solvent, like to dissolve aluminum oxide. We can also mention that. So these are the uses of the cryolite. Then write an ionic
So
equation for
dissolving.
aluminum oxide is
Dissolving.
dissolving aluminum oxide. Like aluminum oxide is dissolved in a cryolite. We have a lot
So
of
cryolite is liquid.
yeah, cryolite is like a mold. It's also a molten substance, but you can say consider it's a liquid and it dissolves aluminum oxide. So cryolite is actually acting like a solvent. Then write ionic equation for formation of aluminium. How aluminium can be formed? So we have because we are doing electrolysis of aluminum oxide, so there will be aluminium ion and there will be oxide ion. So where aluminium ion will move, positive or negative? The cathode, this is cathode, this one is
Negative.
anode. So aluminum ions are moving towards the base and the wall. And what will the equation for this aluminium? Equation
So
for,
this is a reduction.
yeah, it's a
Yes.
gain of electron, that's true, it's a reduction. But we have to write an ionic half equation. So aluminium is +3. It will take 3 electrons.
Plus 3E is equals to Al.
Al plus 3 take 3 electron and turn into aluminum atom. Then how the carbon dioxide gas is formed at anode? So what happened? The oxide ions, basically what happened? It contained an oxide ion, the solution, and aluminum ion. Aluminum ions are moving towards cathode and oxide ion towards anode. So when this oxide ion move towards anode, when one oxide ion is there, it will lose 2 electrons and form oxygen atom. But when 2 oxide ions are there, they will lose 4 electrons, it will form oxygen gas. This oxygen gas which is produced will react with a carbon because this anode and cathode are made from carbon. So the oxygen gas which is produced will react with the carbon and it will form a carbon dioxide. So the size of the anode will start to decrease because the carbon is reacting with oxygen. So the question is why, like how carbon dioxide gas is formed at anodes. So answer, the oxide ions or oxygen formed at anode. 1 mark for this. React with carbon at anode due to high temperature. And as a result, it will form carbon dioxide. So the oxygen formed at anode, 1 mark. React with the carbon at anode, 2nd mark. Due to high temperature, 3rd mark. Is it clear, this one? The formation of a carbon dioxide?
Yes.
Yes, sir.
Okay. Then a piece of aluminium is placed in a dilute hydrochloric acid. Like you have a beaker, and this beaker is filled with hydrochloric acid, which is dilute. When you add this piece of aluminium, you find it does not react immediately. There is no visible change. But if we leave this aluminium for several hours, then the bubbles start to form. Explain why the aluminium does not react immediately. What is the reason for that? Whenever you have a piece of aluminium, its top layer is not aluminium, its top layer is aluminium oxide. And this aluminium oxide does not react quickly with acid. So the answer for this one, like aluminium is coated with an oxide, unreactive oxide layer. That's why the reaction does not start immediately. Once, like if we leave it for several hours in acid, then the oxide layer is removed and the aluminium start to react with an acid. So at first, what will happen? Aluminium having unreactive coating of oxide layer, which reduce the rate of reaction. Like it does not react immediately. Once this oxide layer is removed, then the reaction will start to occur or happen. Before that, there will be no reaction. The next is iron is extracted from its ore using a coke in a blast furnace. Name the ore of the iron, which is mainly iron oxide. What is the name of, like, ore of aluminium is bauxite. Ore of zinc is zinc blende. What about the ore of iron? What we call that?
What do you
Ore of the
mean,
iron.
sir?
The common name of the ore of iron. Ore means like naturally occurring
Iron
compound.
ore.
That is hematite. You have to learn these names. So hematite is actually the ore of the iron. Bauxite is the ore of aluminium. Zinc blende is the ore of aluminium. Zinc. And copper pyrite is the ore of copper. Describe the reaction occur in the blast furnace. Two reasons why coke is added in the blast furnace. Then the chemical equation for reduction of iron and explanation of the using of a limestone. And it's of how
Sir,
many?
what coke, sir?
Coke is a carbon. A carbon. So
Okay,
why?
sir.
First, what happened? Like in the blast furnace, when we add from the top, we add a coke here, a carbon from the top, and hot air is blown from the bottom. So as a result, first what happened, carbon react with oxygen to produce carbon dioxide. That is the first reaction, and this is a highly exothermic reaction which produce heat energy. That is the one reason we add carbon. So it react with oxygen to produce heat and increase the temperature of the furnace. And second thing, it is used as a reducing agent, or it is used to produce a reducing agent. The second, what happened? The carbon dioxide which is produced react with more carbon and it produces carbon monoxide. And this carbon monoxide react with the ore of the iron, which is iron oxide, and it will form iron metal and carbon dioxide. This iron metal, it will move towards the bottom of the furnace and the carbon dioxide gas will escape. But why we add the limestone or the calcium carbonate? So this limestone or calcium carbonate, it decomposes because of the heat in the furnace, it decomposes into calcium oxide plus carbon dioxide. And this calcium oxide, which is a basic oxide, react with the sand, the silicon 4 oxide, and it will form calcium silicate or a slag. So the main purpose of the limestone is to produce calcium oxide. Then calcium oxide can react with the impurity silicon oxide or a sand to form a slag. So the first they asked, like we have to write in steps the reaction, two reasons why coke is used in a blast furnace. So produce heat, that is one. And the second is to produce reducing agent, which is carbon monoxide. So these are the two reasons we add coke into the blast furnace. Then the equation for each, if I want to write the equation, the first one, to produce heat, the carbon, the coke, react with oxygen to give carbon dioxide. The second one, produce a reducing agent. So carbon dioxide react with more carbon to produce carbon monoxide. Then the third one is a reduction of iron, ore of iron. So how iron ore is reduced? So this iron ore, which is Fe2O3, reacted with carbon monoxide, which is a reducing agent, to produce iron metal plus carbon dioxide. Then we balance the equation. We have, like, if we put 3 here, oxygen is 6. We put 3 here, oxygen is 6. And then iron 2, so we put 2, iron is 2, and carbon is already 3. So this equation is balanced. So the main purpose of the coke, first thing, it react with carbon, like it react with oxygen to produce carbon dioxide and produce the heat energy. The second is it react with carbon dioxide to produce carbon monoxide, which is a reducing agent. And then carbon monoxide remove the oxygen. So it's a redox reaction here, removal of oxygen from iron and addition of oxygen to carbon monoxide. So it's a redox reaction. Then why we use a limestone? What is the purpose of using a limestone? So limestone, it decomposes. So limestone decompose to produce calcium oxide, and the calcium oxide react with the impurity silicon 4 oxide, or you can say sand, to form a slag. So first thing, what happened? The calcium carbonate will decompose. So the decomposition of a calcium carbonate due to the heat energy decompose into calcium oxide plus carbon dioxide. And this calcium oxide, which is a basic oxide, react with silicon oxide to form CaSiO3, which is known as slag. Is it clear? So you have to learn this extraction. You have to memorize the steps of this extraction, how iron is extracted in the blast furnace. Any question in this?
Okay, sir. No, sir.
It's only confusing.
Yeah, but still you have to learn, memorize, like this procedure, carbon react with oxygen, give carbon dioxide. Carbon dioxide react with more carbon to give carbon monoxide. Carbon monoxide remove the oxygen from iron to give pure iron, like iron and the carbon dioxide. And then limestone is added to remove the sand or the silicon 4 oxide, as it first produce calcium oxide, which react with silicon 4 oxide to form a slag. So it always remain like this, the answer.
How much?
6 marks are there for this. Describe a bonding in iron. For any, even actually, they can name here any metal like iron, aluminium, copper, zinc. You always describe and include diagram in your answer. So first, how to draw all the metals, the general structure of the metal. You will draw a lattice or a regular arrangement of the positive ions. So lattice of a positive ion and the delocalized electron, mean electrons are free to move within the structure. And the explanation here, so it's a giant lattice of a positive ion held together by a strong electrostatic force between the ions and the electron, or lattice of positive ions and free electrons, or the delocalized electrons, or in a sea of electrons, which are held together by very strong force of attraction. So this is always the case. Use your diagram and C1 explain why iron is malleable. The term malleable means these layers can slide over each other without breaking. So why iron is, the term malleable means like we can hammer into shape. And how we can hammer into shape? Because the layers can slide without breaking. So layer slide pass over each other, slip past each other without breaking down or break down. So we call that as a substance malleable. Ductile means like we can stretch and draw into wire. Iron containing a small amount of a carbon, which is known as a steel. Why steel is less malleable? So, like, what is the reason for that? The same idea. Steel is an alloy, and alloys are usually harder than the pure metal. Pure metals are soft and malleable. Alloys are harder. What is the reason for that? Like, if I draw the structure of an alloy, steel contain carbon and iron. So the lattice of a positive ion, and there are impurities as well, like other atoms between the lattice. As a result, what will happen now? The layers cannot slide over each other. So particles of different sizes are there in the lattice. So layers cannot slide over each other. That's why it is hard or it is less malleable. So the alloy, you can say, or a steel contain particles. Even if the journal question was why alloys are harder or less malleable, so you can mention steel or you can use the term alloy. It's an alloy if you use the term, it's a journal answer. It's to contain particles of different radius or size which cannot slide over each other. As a result, it will become hard. And if we increase the amount of the impurity, it will become harder, like less malleable, and it will be difficult to deform that. So high carbon steel, it's rigid as compared to a low carbon steel, which is like more malleable, which can be hammered into shape.